Hello, welcome to stream number 52 in this series where I am programming an NES game live on Twitch from scratch. Today, I think we're going to be tackling some animation stuff. The reason that I wanted to look into that was because last week we got the collisions working the way that I wanted. So I was excited about that because that meant that our player, when the ship is flying, will actually collide with the backgrounds properly. I had the emulation speed down, so now the wings will cause a collision just like the nose of the ship will. So we actually have some pretty detailed collision working. So right now it just causes the ship sprite to disappear. What I'd like for it to do is actually create an explosion when the ship gets destroyed. And hopefully this will set the framework for the rest of the animation that we do in the game. I have this explosion. It's a placeholder. I don't believe we will use this for the rest of, or for the final game, but who knows? We're just kind of messing around with it. I should probably just rename it to explode. All right, so it's just a series of 16 by 16 explosions, and I think I have Sprite on here, right? Just so we can see what it looks like. I'm just trying this out because it, a bunch of people have said it's pretty good. So let's see here. Projects. Yes, as a tool. So 16 by 16. Okay, so that's what this looks like. If you can see down here, it's that little explosion. So that's what we're shooting for, to make that work. So I've imported it into the asset tool already. I have no idea what's going to happen when we export this and try and bring it into the game. I mean, I assume that it should work, but at the same point, it's possible that we're going to run into a problem because of the size of the thing. If we look at this, the draw entities, I assume that this probably brought in, let's see. Yep, so this actually brought in a bunch of code for drawing the explosion as is. So that's kind of interesting. I mean, it's good that that worked, right? It in theory is not bad that did what it was supposed to do, but unfortunately the problem is, of course, that the changing the capitalization, so when we export it, it's capitalized in the code here. It's technically not wrong that it's doing what it's doing with these sprites, but it's however many frames it is, and it's 2 by 2, so that's quite a bit of sprite real estate that it would be taking up if we were to render it directly. So what I first want to do is just see how this gets brought into the game, into the char ROM, and see if this looks reasonable. And then after that is in, what I think I want to do is see if I can get the animation playing properly on the NES, see what that looks like with the 4 sprites, and then figure out how the asset tool will generate the information we need. Because up until this point, we haven't really dealt with the sprites that much. We don't have the palettes for the sprites. We don't have any concept of animation for the sprites. We've just got those collision points for the player. So let's bring all of this in first, right? So we've got this. And I'm going to take out draw entities because I don't want to draw the entities right now at all. Copy. Replace. Alright, so if we go back to this and we build. Alright, so CC65 didn't complain, which is good. And if we reload this, let's go take a look at the PPU and see what it's showing in the char viewer. Okay, good. So those are the explosion graphics. That's cool. And then if we hit start, we should, no, we don't see the ship. So I think that's probably because, like I've said in the past, we're kind of hacking some of that. So we'll have to figure that out in a second. All right, so that's actually good. That's got the frames in there that I expected. I don't know that we would actually be able to use this as is, but we'll figure it out. Right now, like I said, the palettes aren't even being loaded properly. So maybe that's the first place we start, is right now none of the sprite palettes are working. We have a few different sprite palettes. We can have up to 4 at a time. We have this sprite, we have that sprite, we have this one, we have this one, and we have the player. So I'm wondering if we can first consolidate a little bit, just in order to minimize the number of pallets we have. Or maybe even we'll take the blaster out because we're not using that yet, and it'll be simpler to just deal with 4 different sprites for now. So why don't we do that? Why don't we take that out for now, just for the sake of simplicity. Where's the PNG? I don't want to get rid of it because I kind of like the way that that looks, but we don't need it. All right, so we'll re-export this. Go back. And again, well, you know what? We'll keep the draw. We just gotta change the player draw, because right now we do this. Here, let's do this. Let's copy that just so I don't have to remember what that looks like. We'll just replace everything in there. Okay, so draw player, and that needs this. And again, this is all stuff that we really need to figure out how to make work in the asset tool. So all right, so draw entities is now having out of range issues, which isn't surprising because the explosion is quite a bit larger than the rest of the sprites were. So let's see, should I change? Change this by hand. Branch not equal to the next label, and then jump, and this is our next label. And then what's the next one? 14. Branch not equal to the next label, and jump to that, and then oops. That's that. Okay. So that's good. Go back to here. All right, so that's looking good now. And just to make sure, let's go back to the PPU viewer. Look at this. Okay, good. All right, so right now we're loading the background palettes, but we're not loading any of the sprite palettes. So I think what we'll need to do in the asset tool is add, similar to what we're doing with the metatile palettes, we'll have to export a set of the sprite palettes. So let's see here, what are we doing? So we have the metatile palette table. So I'm going to leave that open. We don't need that. This is the metatile palette table, which has, okay, so we did, that makes sense. We had the array of, or the list of our different metatiles, and then the palettes that went along with them, and then these are the individual palettes that actually got loaded in. Alright, so we'll want to do a similar thing. I actually wonder why I broke that up into two files. I mean, given that they're logically associated, it doesn't make sense that they be separate. Let's make it one file. You know what? Let's leave that alone for now. I don't want to mess with that just because I'm getting sidetracked here. I want to focus on these sprite palettes first. So what am I doing here? I'm looping through the metatiles. Looking at the map metatiles that actually exist, and then MT tiles, where is that? MT tiles as metatiles bin, so it's actually writing the metatile raw data out. And then, okay. All right, so where's our code that's handling sprites? So that's this. So that's checking if it's a sprite and generating our branching conditions. So let's do similar thing here. And I realize that some of this is not exactly the most efficient way of doing this because, for example, I'm doing many iterations over the items that I have in the list, but part of this is just I'm trying to figure out exactly what we're even doing with the way we're handling all of this. So once we kind of have it working, I can always come back and make the asset tool more efficient. I mean, I'm not 100% worried about that, you know, because ultimately the number of assets, this is not a AAA game by any stretch of the imagination where you know, you have gigs and gigs of assets that have to be loaded and converted and compressed and all that other stuff. This is a very straightforward approach that we're taking for a very simple NES game, and so we're not dealing with huge amounts of data, and we're not even in a situation where the tool is having any issue with the export speed. So I'm not really worried about this. So let's see. So level 1. All right, so that's what that's doing, if I remember now. So level 1 has within it the information about what palettes it's loading. Those palettes are the metatile palettes. So I wonder if it makes sense to add the sprite palettes into level 1 too, also. What I'm thinking is that, you know, I mean, right now we only have a fixed number of sprites that we're dealing with, obviously, and what we want to do is kind of keep it so that we can have just the 4 palettes for the level. Wondering if I can maybe reuse this approach. Sorry, I'm just kind of trying to think of if there's a way that I can reutilize this. I don't even know that it matters. I think probably what we'll do is we'll write the map palettes. This map lookup is the normalization of the map metatiles from the denormalization of the map metatiles from the normalized form to the raw. So what I think I want to do is work on it in here where we say I can't use I. Go through and say, okay, if this is a sprite, so we want to output the sprite palette file. Do we have a sprite palette file? I don't think so. I think we just have metatile palette files. So, all right. Sprite. So that gives us our load, and then palette is just a 4-byte. Okay. Oops, stop that. Alright, so that's just a 4-byte value. Now in here we're just writing 4 bytes to the palettes themselves. This is kind of not... See, part of this is that because I'm doing it in bits and pieces, it's not exactly flowing the way that I guess it should. Now that I'm kind of bringing in more and more pieces, this can all go away. This was that old format that we were using. So see. I guess what I'm gonna do is I'm not gonna loop through this right now and examine any of the sprites. So I guess what I'm gonna do is just should we just do a brute force 0 through 4 or 0 through 3 palette for the sprites for now? I want to add it to the map because I think that it's worth doing. So that once we actually have some more logic behind it, it'll work the same way. So bear with me. This is obviously not ideal, but what we're gonna do. Let me make this an unsigned char. So what I'm going to do is I'm going to write just basically 0 through 3 into the map. So it's going to add 4 more bytes into the map, which is going to break things, but we'll fix it right away. It's not that hard. But the reason I'm doing this, hardcode, the sprite palettes, just lookups. The reason I'm doing it this way is because I just wanted to kind of work for now. Like so many of the other things that I've done in this project, I'm trying to just move us along relatively quickly and do my best to figure out what's going to be a good strategy moving forward, even if it's not the best or permanent solution. And then we can go back and rework it as we find out more about how this is actually supposed to work. Oops. Wait a minute. Why did... That's weird. Why was none of that stuff there? Did I delete it accidentally? I guess so. Right, weird. Okay, so I don't know why I did that, but sure. Right, okay, so let's fix this again. That, and then for the sprites, for the player sprite, we got to add that check. Let's make sure that we didn't totally destroy this. The map won't load properly because it's going to be offset incorrectly, but that's fine. All right, so in our code where we're loading level, we do our palette loop, and then we need to add 4 to this. Well, okay, so load A, no, so this isn't quite right. So what we want to do is, I think we can just load Y, the raw value here. Although, let's do it the right way. So we'll just increase Y 4 times to skip to the lookup, and then this would mean that y is no longer 9. 8 is 9 plus 4, 13, which is 10. Let's C. And then we need to offset, when we're doing this calculation, we don't want to add A. We want to add, we have the 1 byte, we have the 4 bytes, the 5 bytes. So it's not 10, it's now 14. So what is that? That's E. So let's see if that loads correctly now. No, it's still off. Is my math wrong? Well, obviously my math is wrong, but why is my math wrong? What did I do? That's 0, that's the row count. Then we sprite mem 0. Where is it incrementing y? Store max rows. Increment level mem plus 1. Let me think about that. It's 1 byte for the row count. It's 4 bytes for the pallets. So that's 5 bytes plus another 5 bytes for the offset. That's 10. Should it have just stayed A? Where's my Word document? Row count, map palettes 4 times 1, map metatiles 5 times 1. So that's 10 bytes. So that's that. And then we added 4 for the sprite palettes. So 10, 14, right? So 15 is F. So that should be E. So we got our row count at 0. Shouldn't this be incrementing 1? Oh, it increments sprite mem. Okay, right. So so that increments sprite mem, which is what we have to. Okay, right. So now it's using Y and getting the palettes loaded. It compares it to 4. That's good. We load x0 and then we increment y by 4 to skip past the sprite palettes for now, and then we do our tile lookups at that next value, and so that should that be D? Now, why are we off now? Oh, because, right, because it's at the end, I think it skips past some of this stuff. The first screen isn't even right. Why? I've got to make it so changing the map is easier, because adding 4 bytes should not cause this to break. Or at least the it should not cause the amount of problems it causes. Let me think about this. So we've got 1, and then it's going to be 5 at the 4 at the end of this, and then it's going to be 5, 6, 7, 8, and then we've got another 5, so that's 13, 14, 15. Okay, so 15. This should be D, and then that's okay. Load a sprite mem. Sprite mem is the beginning there. Add carry temp. Add ROM address to temp and temp2 in order to seek into map properly. Add 8 bytes minus 4 bytes for the palette indices, and so this is not okay. So that's the other problem. So this should be also 13. A B C D. So add 13 bytes for 4 bytes for the palette and the indices, 5 for the palette lookups, and 4 for the sprite palettes. Fix it finally. There we go. Except now what? Now are the collisions broken? Seriously? Oh, for crying out loud. I think it's just slightly off. Let me make sure this is working the way I want it to. Sorry, I was not expecting to have to debug this nonsense here, but apparently we're going to have to. So level mem is E4B8. No, it was EFB8, even though I said E4B8, right? EFB8. So 64, which is, I think that's right. I think that's 100. Yep, 64, and then we have our 4 palettes, and then our 4 sprite palettes, and then our 5 metatile lookups, and then that's the first. What is that? Did I purposely? I think I purposely put a non-empty tile at the top corner. I don't remember, but I want to make sure. Yeah. Okay, good. So that is the right position. So that is what is that? That's EF6 C6 EFC6 minus EFB8. So that's E. I'm just really EF. Oh no, don't write into that. EFB6 C EFC6 minus EFB8 E. I have D. That's 15. Why is it 15? 1 5 9 14 It's not 15, it's 14. Let me tell you, it's been a long week. So I'm not totally surprised that I'm making dumb mistakes. So oh right, so here we skipped, so that can be C. Let's see if we got this right now. I mean, it was loading the. Okay, well now it's consistently off by 1. Oh man. Okay, what the hell? Okay, so it's so it's consistently off by 1. So should this be D, and that should be E? Is that where I screwed up? There we go. Okay. Everything's happy again. Great. All of that to add 4 bytes. So let me do this before I forget again. Let's do some commenting to remind me. Note, if modifying the map, this has to change. Yeah, so we're just going to do that in all of the appropriate locations. Same thing here. And same thing here. And same thing here. So at least those are going to draw attention to the places in the code where the map update will occur. Alright, so we've got that working now, and what I want to do, obviously, is now actually load the sprite palettes. And Right now, we don't have any of the sprite palette data anywhere. So let's do something about that. So I'm going to include sprite palette table and sprite palettes. Same deal. All right, let's just kind of have it follow the same format here. So what we need to do is actually get that all written out. So I'll just steal this code that I had written before to iterate through our sprites, and let's do this right here. And what I think we're going to end up doing is finding better ways to kind of organize this export stuff and make these reusable functions, but for now, in the interest of time and patience and getting stuff on the screen, let's make sure that this loads the sprite properly. It does. It's got the bounding box. It's got the number of bounding boxes. It's got no collision points. It has the width. It has the palette. It has the file. Okay. So right now, let's just focus on writing out the palettes. So this is going to be a text file, so we'll do it just using fwrite and fopen and whatnot. So file sprite palette table and then we also will need for the individual files that are binary. Okay, so it's fopen s. What did I call it? Sprite palette table inc write fprintf. Include file header. It's just our usual little thing about it being auto-generated, and then we want to actually doing this in the wrong spot. I want to do this outside of here. And I want to first do the define of the sprite palettes, and then we're going to do our list of sprites. So All right, so do I have, I'm sure I must have a constant somewhere here. How big is that? I have to increase that size. Except this is going to have the dot sprite part, which we don't want. Yeah, this actually modifies the thing. File extension temp, and then we'll write temp. Or I should say we will concatenate it here. And then we will have our sprite list, and sprite list 0 will be equal to space, because we know that it will have an extra comma, which we don't need. And then sprite list string length of sprite list minus 1 will equal 0, because it's going to have the extra comma. No. It won't have the extra comma. Okay, yeah, that's good. We don't need that. All right, so let's make sure this looks right. And I know I keep saying this, but I promise we will go back and fix the way that the asset tool is doing all of this stuff. I know it's kind of gross. I have no excuse except that it's not important right now that we make it work, make it do anything other than work. So. Plus, I feel like that's way less interesting, but if you disagree, I'm happy to do all the refactoring and reorganization of the code on stream if people think that that's going to be something they want to see. All right, why does it have an extra space with the sprite list? Oh, because of that. Whatever. Okay, it's just a space. It doesn't matter. All right, so we've got that, and then we need the high and low part of it. All right, so and that's relatively easy to do. That is just our let's stop debugging. We'll do an extra new line, and then sprite palette. It's high, new line. What does that look like again? And then it's just tab. sprite palettes, and then new line, sprite palette. You know what? We'll break that onto another line here, just for the sake of readability. Sprite palettes. Okay, so that's going to write out our sprite palettes table file, which is this, which is good. So now we've got our 4 sprites, which means we will have our 4 palettes that we can load. All right, so now let's actually write out that info, which will be in Sprite Palettes Inc. We can actually reuse that. So now let's do fopen-s sprite palette table. All right, so now we're just going to do a similar thing to this, where again we're going to have the name of the thing and generate the ink bin, and then also generate a .palette file that will have literally just the 4 bytes of the palette. All right, so we've loaded the sprite. We're going to have our temp. We're going to do our string copy s to temp. Well, we're not doing that here. Should we do that in this loop? Yeah, you know, we should do this in that loop, so we're not redoing all of this stuff here. So, all right. So we're going to have our sprite palettes file here. We have the remove of the file extension, but what we can do is we can load the sprites to current sprite. Full path, and then we have the removed file extension name, and we're going to concatenate it to this list that we've got, and then we do fprint f, and we're going to write to sprite palettes. Let's make this consistent, and we're going to have the temp, which is the the sprite with the sprite name with the extension removed, and then we're going to do tab, and then ink bin, and then temp.palette, right? And then new line, actually need to do that. We actually need to, let's close this file here. We actually need to write the binary file. So we'll do, what is it, underscore open s. Oh, what the hell is it? S open s, and then what is that thing called sprite palette? And this will be add extension, add file extension. What did I call it? Or change. Hey, you know what? We just do a string cat s to it. Temp palette, the max file folder name. Then we're going to open up the file named that, and then read, no, write only, binary, create, and then we have the share flag, which is deny no, and then one of these days I'm going to remember it all. SI right. There we go. It's close. I almost had it that time. All right, and then we're going to write sprite palette. Current sprite. Palette 4. Right, that should be already an array of 4. It is. We write it and then close the file. What's the matter with this? Oh yeah. Because it helps if we actually use the parameter. All right. So let's export that. Did not crash. That's a good start. So that's that, and then we should have the new files. We should have the individual sprite palette files, which we do, and then we should have the sprite palettes. There's metatile palettes, sprite palettes ink, bullet ink, bullet palette. Okay, so that looks good. And then let's grab the palette files. I think that's all of the ones we needed. Let's see if that builds. We may not have. Okay, I didn't pull all the files. Flyby. Oh yeah, I missed them. So there's flyby and bullet and player. Alright, so that compiled properly. Now obviously it's not going to have the palettes loaded because we did not actually do any loading yet. We will get to that in a second. I just want to make sure that everything is still looking good. Alright, so now let's work on loading the sprite palettes. So I have this call for load palette, and it is using those parameters to say which palette is loaded. Now for the sprites, their palettes are the second set of palettes, and if I'm remembering correctly, I think we just can just go and start at 4. So let's see here. param sprite. Okay, yeah, cool. So where we are loading. Okay, so this is the part where we are loading the sprite palettes. So what we would want to do, let's make this a loop 2, sprite palette loop, load a sprite mem y, store a, param 1, store y, param 2, call load palette. So I'm going to need to change that in a second here. Branch not equal to palette loop. So load palette right now, I believe is just, yeah, so it's looking at palettes high and low, which is fine for the it's fine for the metatile palettes, but the sprite palettes are different. I'm just wondering if it makes more sense. Here's what I'm going to do. I'm going to introduce param 3. Oh, kind of hate to add another parameter just for that palette. Let's do this. If if bit 7 is 1, then use sprite palettes. So basically what we'll do is, let's see, load a param 2, and 80 branch if not equal. I always forget if this works the way that I want it to. 6502 skill tree. I don't remember. Not ski. So if I load a with this, let's say this, and then I AND it with that, I assume that it's branch if not equal. Let's see, branch if not equal to this next label. Otherwise, load a with FF. So that's fine. And then if we say this and assemble and run, okay, yeah, that's okay. So I just wanted to make sure. I was pretty sure that by doing the AND, it would affect the evaluation of branch if not equal. Because if the bit is not set, then it will be considered the same as comparing and getting an equal. So AND with 80, branch if not equal, branch if equal to, we're going to load the sprite palettes, right? Load sprite palette. No, branch if not equal to load the sprite palette. Jump to set PPU memory. Here. Jump to set PPU memory there. No. That's there. Okay. So load x param 1 and then load a sprite palettes high. Right, that's what I called it. Yep. Sprite palettes high x store a outer param 1 plus 1 load a sprite palettes low x store a outer param 1, and then we're at the point where we're going to actually load the memory. But what we need to do is store that back into param2 because we're going to use that here. So, all right. So let's do this. So the sprite palette loop. So param2 is fine. Store y param2, load a param2. Well, let's do this. Transfer a to y, and then or a with 80, and then store it, and then we're good. And that should do. No, transfer y to a. Sorry, that should do what we want. Sprite palette high. I just spelled it wrong. Yep. Okay. So let's see here. Let's see if we get the all right, well, that's obviously not working. You know what? Wonder if I have. I shouldn't have. Yeah, okay. I don't have a duplicate label. I wonder what would happen if you try and define a duplicate label. Does it care? It should. Okay, it does. Great. I hadn't tried that to see what it did. All right, so obviously there's a problem. Most likely it's with this part. So let's see. So we're taking sprite mem, which is now at 4. So this is our sprite palettes. We're storing a, which is that value, into param1. We're transferring y to a. We're doing the or a to set that bit. And then we're storing it in param2, and we're doing the jump to load palette. Then we're increasing the palette value. Oh, because this should be sprite palette loop. All right, so that's better, but now we are not getting. I think it's probably not loading the sprites into the appropriate the palettes into their appropriate locations. Let's do this. Let's make sure that by not calling that, it doesn't have it goes back. Okay, so that's broken. I wanted to check what was actually broken about that. So load a param2, if do an AND against store it in. Oh, well, no, you don't want to do that because that's going to break it, dummy. Don't do that. Load a param2 and then do an exclusive OR where we're going to use all the bits except for the 8th bit, so it would be 7F. Basically, I want to remove that high order. No, that's not right either. I want to do an AND. I want to keep all the bits except for that highest order bit 7, if it's set, because that's the flag essentially to say, okay, we're loading a sprite palette there, and okay, so that's working correctly now. So now let's make the call come back to try and load the sprite palettes. So we should see, okay. So let's take a look. So it obviously affected the sprite palettes. What are they? So this is 0, all 0. This is interesting. So it's okay, let's take a look at what palette values actually got written out, shall we? So for the player, for example, 0D001022. So that's not what was loaded, obviously. Alright, well. So, and this branch, if not equal, it said, okay, if it's not equal, then it's not equal to 0. Which we're loading the sprite palette. So, and then we're doing the same logic here, except it is using sprite palettes high and sprite palettes low. And then, okay, and then we are taking param2 and we're multiplying it by 4. So if it's 4, we're going to get 16. And then we're going to add 1 because that's going to be our, yeah, so that looks right. Let's just take a look at the address range here. So 3F11, that should give us, let's see, so it would be 4 times 4 plus 1, which is, yeah, 1 1 in hex. 3F11, right, because it's only 1, 2, yeah, it's not including the background palette, and we're skipping that too. So that part is okay. We're loading the palette value. I'm just not getting real palette values in there now. Let's take a look at how it looks in the debugger. Yep, okay. Alright, so Y is 4, so when we do the load, A is 0, which is what I expected. Store A, transfer Y to A, does the OR, so you get that bit set. You store that into param2. We do our subroutine, so that does the storing off of things. We're going to load that. Wait a minute, why didn't it transfer Y to A? Oh, because it's storing Y as param. Yeah, that doesn't work. So, okay, now the value is 8.4 like it's supposed to be. And it's not equal, so we're loading the sprite palettes. Good, and then we're going to load that into the PPU. Let's see now what that looks like. Okay, now we're getting somewhere. So it looks like it actually loaded new palettes in there. And let's take a look back at the sprite palette for the player 0010 and 22. There it is. Okay, so now we've got the right sprite palettes in there, which means actually if we go to the char viewer, and let's see, we should be able to choose. There it is. So now our explosions actually have the right palettes loaded. So they look correct. And if we choose Sprite 3, Sprite 3 should have been right for the player ship, but that actually looks wrong. Why? Why is the player using this palette? That's Sprite 0. This is still, is it because, why? Why is that? Yeah, just show me what I'm choosing. That's why. Okay. It's trying to be helpful and show me what the palette is based on its last known palette value, which is useful when you've actually got your palettes working right, but because we're still working on it, I just want to see literally the raw char ROM with the sprites, with the palettes that I am writing out. So that is good. What's interesting is the way that that is manifesting. But anyway, okay. So now, let's see. How do we know? How do we know? I guess it's based on... Okay. So what I was trying to think about and not verbalizing properly and just repeating, how do we know? What I was wondering is, how do we know which palette the player sprite is supposed to use in the rendering code that we've generated here, which, spoiler alert, is probably going to change because hard coding this is likely not right. So right now we're just hard coding. This is 0 value for the sprite palette and the mirror bits. What we need to do is take a look at the OAM sprite data and find where the definition of the palette is. So, alright, so that's those 2 bits, and so the value will be 0, 1, 2, or 3, and that is actually easily accomplished by doing what? By doing a count of what current sprite we're on, because the order will be the same. So let's do this. We'll say current sprite index equals 0, and then where is this? This is now this, and becomes current sprite index, and then once we are done with that, we can increment current sprite index. Or do we do it in here? I guess we do it in here actually. So this is different from the current item count, because the current item count is the total list of items. So when we're done here, all right. So should now, for the first time, actually have our player sprite using the appropriate sprite palette. Again, in a rather sort of janky, hard-coded way, but you know, it'll work for now. It's workable. Fairly soon we're going to have to fix this, but that's okay. Replace. And then let's go to draw entities, because draw entities is what we changed. We need to add to the player sprite this, and then let's see, so it's writing, yeah, that's good. That actually looks like that will work. Oops, not if I just randomly paste crap into my assembly code. Oh right, this whole out of range jump. Oh, damn it. That's not the right place to be changing that. Branch unequal to next label, otherwise jump, and then what's that? Okay. Let's reload the emulator here. And hey, the player sprite actually has the right colors. So that's cool. If we turn that back on, then that's going to show that, and that is actually the right set of colors. Now this is not, but we haven't actually used that for anything, so I'm actually really curious to see. Oh, that's got green. I wonder why that is. Those are right. Why is the bullet green? Why is the bullet green? Is it just in the asset tool with the wrong palettes? Let's see. Where's the bullet? Here's the bullet. Here's the, oh yeah. Well, that would explain it. I don't remember why the colors are wrong for that, but okay. So we can fix. Well, you know what? I don't even remember. Is that what it's supposed to look like? It's been so long since I've looked at what that looks like that I don't remember if it was supposed to look like that or not. Not that it's the final artwork or anything, but like it may be that that's actually right. What does the PNG look like? Besides ridiculously tiny. I guess that is right. I just we haven't had the sprite palettes working, so I forgot that it was green like that. All right, so now we actually have that looking right. So let's do this now. So now what we want to do, or what I want to do before we wrap for tonight, is I want to get it so that I have code. I'm gonna basically do this. I'm gonna introduce a new state into the game that just populates the sprite memory with the information necessary to, well, does that make sense to do? Maybe we use the entity loop and we create an entity that's an explosion entity, and then we kind of hand hack that together. Maybe that's a better approach. Let's do that. I was going to say I was going to add a new game state and make that work so that we get the explosion to appear properly, but I think that it's going to be better if we do a couple of things. One is, let's get the just like with the player, let's get the entity in there for the explosion. Right, and I think, if I remember right, the types are generated automatically by the asset tool. It is. Alright, so explode is number 2. So this is where we are initializing the player, right? Let's do load load x 0 1, and then so what I want to do is I want to essentially get this working to get an understanding of what we need to modify in the assembly code, and then we'll kind of piece together sorry, I'm just kind of like thinking about this as I'm trying to find my spot here. So what I want to do is I want to first get the sprite for the explosions loading on screen. They have the appropriate palette already configured. I want to then figure out how to change the draw entities code, and I kind of have a thought on how I want to do that to make that work where it cycles through the explosion. So we get that animation happening, and then we can kind of talk about where that fits into the asset tool and the state engine and all that other stuff. So let's see. This is all of our scrolling code, their attributes. Initialize the sprites. So that's initializing the raw sprites. Sprite isn't finished, so it's checking the control. Excuse me, checking controls. Checking if it needs to add entities. Now, I thought there was something where if it has to, let's see, if it has to add something, it's going to look and find a spot in the entity list where, okay, where it's no entity. So that may just appear now. No. Why? Load x 0 1. Is it too many things happening? Let's do this. Let's change the position. Let's just make it at 0. All around. Oh, you know what it is? Well, it shouldn't need to have anything to process the explode type. It shouldn't need anything to process the explode type because there's no logic behind it. It's let's take a look. Sprite viewer. There is nothing. Nothing? Okay. Why? So we're storing that in entity's type. This should be right. Let's add flyby, process entities, jump, skip entity. So that's if it doesn't know what it is, it's going to skip the entity. So I assume it's going to get to the explosion and just be like, yep, I don't know what this is. So it's going to go to skip entity, which is here. Okay. So that's fine. Process entities. Load A type X, yeah. And then the drawing of the entities, draw, explode sprite. That's if the type is explode. Let's take a look at the code here. So yeah, I want to see if it's doing that actively anywhere. Yeah, so it doesn't know what it is. A type X. What is X? X is 0. X is 9. That's weird. Why? That's for no entity, but this is not no entity. It's for explosion. Let's hit the breakpoint here. So the first one, it should be the player. It's not. What? That's weird. Why is that? So the first thing it does is it stores into entities, entity with no offset, and then it loads. Let's see if that's actually doing what I think it's doing. I mean, it should be, but entities, where is that? That's 93. So the first entity is there, and let's see how. All right, so we've initialized the first entity, and that's fine. The following entity, read for v blank. Type player. Player is 4. So where's that 4 value? Here. So that's the next entity. So it should be loading X with 1. And then it should be loading A with 0, and then should be storing that into the X position, the Y world position. Wait, what? Oh, because it's not X, you dummy. Or it is X, but it's not 1. It's size of entity. So I broke the. I forgot. It's not in. It's indexing the X based on the size of the entity, not just by one element. Close the memory. Okay. So that should. Okay. I don't know why the player. Size of entity. So why isn't the player still there? It's better. It actually has the explosion up here. PPU viewer, sprite viewer. Let's offset this a little bit so that it actually fully appears on screen. And restart. What is the maximum file size of an NES game? So from an NES game, the maximum size. So the maximum size can be anything technically. The challenge is that the CPU can only address 64K. So basically what your limitation is how much can you address at any given time. There are the different mappers that NES games use. So when you look at your memory here, you have 2K of RAM, and then as you go, depending on how your code is written and what mapper you're using, you have your memory at your code and your graphics at different locations in memory, and the ROM and the PPU memory. Because let's see, so if you go to here, so all of this is actually the code that's been assembled. So you have the short answer is, depending on the mapper you use, you have different options. So in previous streams, what I had done was I had switched to the MMC3 mapper. And if you go back and watch those, you can see how that works. But real quick, MMC3 has a lot of options, including being able to set a timer that flips, that triggers an interrupt after a time elapses. Yeah, that was MMC3. But it also has all of these different configurations that are switchable. So I think Kirby for the NES, I want to say it's a whole megabyte. It might be 512K, but I know there are projects that people have done where they've done things like store, I think, digital music on the cart and stuff like that using different mappers. That's the thing. It's really down to how these mappers interact with the CPU, because the CPU is kind of your bottleneck into how much data you could put. Gigabytes of data on the cartridge, but the CPU can only address it, say 16K at a time, or 8K at a time, or 2K at a time, depending on how the mapper is exposing it. And so that's your limitation, right? Is that you're going to constantly be having to flip through the addressable regions of your storage on your cart. Yeah, so it's there are some really amazing things people have done. The other thing that you can do is you can use RAM on your cartridge, just a writable memory, so that instead of having to switch back and forth between the banks constantly, you're always using the same RAM for your graphics, and you're just copying it out of the cartridge onto that RAM at runtime. I'm sort of paraphrasing there because I don't know exactly how that works, because I haven't done it, but that's generally the idea. Most NES games, if you look at the PPU viewer for them in an emulator, you get something that looks like this, where the graphics are just kind of all fully laid out, and they don't generally change much, or they might swap sections of it as you play. and that's because you know, the PPU is directly accessing the cartridge memory for the graphics, the character ROM. But you can do things like that. You can manipulate the RAM on the cartridge to make it more dynamic. In fact, if you've ever played the game, for example, Metal Storm, that's something that it does to give that cool parallax effect that it does when you're walking, where it looks like the background is scrolling out of sync with the rest of the background in the game. So that's a pretty clever machine, the NES, and what people figured out how to do, but you are somewhat limited. And hi, Rabbit Zera. And yes, it should remind you of assembly because it is assembly. It's just 6502 assembly versus x86 assembly or something like that. So, what was I saying? Okay, so I wanted it so that the explosion showed up on the screen, because right now it was okay. So yeah, so you can see the other thing is that the explosion has so many, let's see, 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8. So we're actually hitting, hilariously, without even doing much, we're hitting the 8 sprites per scan line limit. So you can see that because these are 16 by 16, we have 8 here and 8 here. So it looks kind of right, but it's not exactly right. In fact, what we can do, just for the sake of making this fully appear, believe there is a way. Most emulators have a way where you can tell it to pretend that the NES could draw more sprites than it actually can. And if we do that, then you'll actually see the rest of the explosion stuff there. So let's see, where is that? Is it an overclocking? Yeah, so now you see that the rest of the explosion appears here because we told the emulator ignore the fact that there is a sprite limit on the original NES, and so those now appear. But we don't want to do that because the real NES does have that limitation of no more than 8 sprites per scan line, and if we needed this to work for some reason, we would need to make it so that the sprites flicker on screen. Most people don't know that. I didn't know this, but yeah, the flicker effect that you see on most games, that is something that actually had to be programmed in order to make those sprites visible, because the NES just simply doesn't draw those sprites. Alright, so that's good though. We've got that sprite. The one thing I'm trying to figure out here is why it is that we don't have the why don't we see the ship on screen. Now my guess is that there's still something partially wrong here, so let's go to the memory. I believe it was at 93. So is it still, am I still being a bonehead with the way that I'm writing this? Let's see here. Okay. So let's restart the emulation here. Alright, So x now has, why is x still a value of 0? Do I have to do 1 times? Like that? That would be a little goofy, but okay. What am I missing? Oh, right. You need the pound there to tell it that you want it to be the literal and not the address of. Okay, so now x actually has a value in it, which means, okay, so that's what was happening. We were now getting the explosion entity populated properly, but the problem was it was overwriting the player sprite. So let's see, that should appear correctly now. Yeah, cool. All right, awesome. So now let's make this work properly. Now, obviously, like I said, this is not the way I'm planning on doing this is not ideal, but what we need to do is we need to make it so that we can make the sprite get drawn, but with a frame of animation. And I think what we want to do is we want to use the data portion of this to contain the animation frame. Now let's see. So the other thing is that we have the way that this is being drawn across X instead of the way that we would need it to based on the sprite animation functionality. So what we want to do is we want to do some manual modification here. And again, this is not the plan for the final output of the asset tool, right? This is just trying to figure out how this is going to work. So this is okay now, and then what we need to do is we kind of have to go back. Let's do this. Let's take a look at this. I believe this will still look the same. It should still look the same. Let's close the debugger. It does still look the same. But now, instead of having the sprites drawn, yeah, so now the first 4 parts, so you can see here it's actually going across the tops of the sprites and then on the bottoms, across the bottoms of the sprites. And, well, that's kind of cool. So this is actually showing you the sprites regardless of the limitation of the 8 sprites per scan line. So this isn't, but what we fixed here is that this has the top and now the bottom. So let's do that. Let's fix that across the board, right? So that's 16, 0, 24, 0, and then this again gets moved to the next part of the code that handles y equals 8. And then 24, 8, and then we move this here. So what we're going to have to do in the entity tool, in the asset tool, is basically be able to tell the asset tool, okay, this thing is a sprite that has animation, and the size of the sprite is whatever it is, right? In this case, it's 16 by 16. Even though the file that we're working with is much bigger, right? Because the file is a sprite sheet, and so it has everything in it, every single frame of the animation in it, which is not what we want to render when we are rendering this thing. So I am now sort of piecemealing the sprite sheet together properly so that we will end up with, hopefully, something that looks right. So let me see if I did this right here. So 4856, 4856, 6472. So 6472 would be the next set. So this won't be too bad to do by hand, at least right now, just for this one time while we're figuring this out. And then what we will do is we will then start to implement this in the asset tool. 7280, right? 80, oh no, 8088. And then this is 96104. And we're almost done. Okay, cool. So 96104. And then this should just be it. 112, 120, 112, 120. Okay. So now all we've done is just change the order in which the sprites are updated, and that looks correct. So now what we want to use is we want to use the data variable in the struct to determine which frame of the animation we're loading into the sprites. So load A entities plus entity data X branch. Let's see. Branch not equal. Branch equal to. Should I do relative jumps? I feel like that's probably going to be the easiest. So, okay, then compare that to 1, which equal to that one. Compare to 2, range of equal to that. How many frames are there? There are 8, I believe. 1, 2, 3, 4, 5, 6, 7, 8. Yep. So we'll just keep doing this. The relative jumps may not work forever, so we will have to fix that. But if we can get away with it, I'm okay with that for now. Because what we're going to do is we're going to say, okay, not only is it a particular frame we're interested in, but we're also going to say that there's probably going to have to be some sort of frame delay associated with each frame, because not all, if you've ever worked with animation in something like Photoshop, when you're dealing with an animated GIF or something like that, you can tell it, you know, how long each frame is, and that makes sense because in an animation, not every part of it is always going to last for the same amount of time. We need to be able to do that too. But for now, I just want to get this to rotate the animation at a fixed rate. And then we will be able to start implementing what I'm talking about in the asset tool. Undefined label. Oh, right, yeah. I did all these relative jumps or branches, I should say, and then I never defined the labels for them. So here's the next one. the next one. Here's the next one. Should be able to just do this. Of course, there's a range error. No reference to unnamed label. 470. Really? Maybe because of the range error. All right. Maybe this was not the best idea. Branch if equal to, let's just say x1, x2, x3, x4. Oops, wait a minute. Yeah. Because as much as I like the relative labels, I think that I'm going to end up regretting going that path. And let's keep the numbering consistent with the value 3, 4, 5, 6, 7. All right, let's fix that first. That should be it. Okay. Now we still get the range errors, and that's okay. Branch not equal to the next unnamed label, jump, and then that. So we still need to use these because of the stupid limitation inherent in the way that 6502 builds this stuff, but that's okay. Branch not equal. Unexpected trailing garbage. Oh yeah, you don't need the plus there. 40. Oh really? Even that one? Okay. Branch not equal to that, then jump to that, and then do this. Okay. So now we should just see the one sprite, which we do. And if we go to the PPU, in the sprite viewer, we do just have that one sprite, which is excellent. And now what we can do is in the game, let's see. So in our entity definition, we have data and timer. So let's do this. Let's cycle. Let's add a process for the explode. Compare entity type explode branch of equal to process explode. And then what does it do after that? It just jump entity complete. Okay, so what we want to do is we want to increment the timer So we want to load it, compare it to, let's say every 30 frames we're going to increment the animation frame. So let's see, 32 is 20, so what is that, 1E? Right, because it's 31, 30, yeah, so 1E, and then branch if not equal to the unnamed label. Then we will increment this. Let's do this. I was going to just do it in memory, but oh, you know what? It's probably better to do that, because then what we can do is we say load A, this, and then and it with, it's 8 frames of animation, so we want to and it with 7 so that we are doing the modulo, right? We talked about that being a neat little trick for anything that's a power of 2, we can just modulo 1 minus that value, and then we just store that back in. And so now let's see if it starts animating. Oh, that's interesting. So it actually, so a couple of things we didn't do right. So load A 0, and then store it into the timer. Okay, so it's partially working. The funny thing is that it's actually doing it and changing the X and Y value, which we don't need it to do. We don't need it to do that. I mean, we do, but we need to do it consistently across all of the sprites. So let's see. So for the second sprite of each one, we don't need to do this, we just do that. Is that going to be, oh, it is going to be, that's kind of cool. So just so happens that this might actually be a simple thing to fix. So let's see here. Because of the way that the values are working out in hex, it looks like we are incrementing by values that are easily readable in hex. So let's do this. So this becomes 0 because we don't need the 1. So let's get rid of that. That's for this, and then for the Y position, we're not adding anything yet. So, and for this one, we do need to add 8. And then for this one, the Y does need to get added by 8, but this becomes 0. So that's good. And then this does need to get incremented by 8. So that's good. Okay. So now load X. So this is now 0. And this is 8, because I had already modified that one. And then this is 8, and this is 0, and this is now 8. Yeah, this is actually relatively simple to mess with. So let's do that, and then that's fine, and then this is 8, and that's 8, and this is 0. Just get rid of it, and then that's 8 and 8. And again, this is hopefully something we're going to do with the asset tool, so we never have to do this again. But this is how I'm figuring out how it all works, right? Is by kind of piecing it together after the fact. because I had an idea of how I would want it to work in my mind, but given that I'm not as familiar with the NES as I am with, say, doing something like PC programming, it's better to just try it out and kind of experiment with it and learn from the real-time stuff, and instead of trying to guess and then kind of drive myself crazy with asset tool changes that are ultimately going to be fruitless. Alright, so I think we're basically almost done here. I certainly don't enjoy the manual copy pasta, or copy paste if you will. That was a typo I read somewhere, copy pasta instead of copy paste, but I think it's appropriate because you copy paste and get spaghetti code, so it's copy pasta. Alright, so now we should see it in place. There it is. Obviously that's too slow, so we don't need to do 1E. Let's say it's like every 8 frames. Yeah, that looks pretty good. I'm reasonably happy with that. That looks like an explosion in the game. So I think that gives me enough to go on now, because basically what it means is, like I said, in the code that is used by the asset tool now, we have to define for sprite if it's animated. We have to define, that's kind of cool to watch it in here too. We have to define what the size of the animation is in the sprite sheet, so 16 by 16. We want to define a I think we can start with a fixed time just for now, maybe not, I don't know, but I gotta think about that. But you know, some sort of way of timing it, and then we use the data property in the sprite. Or maybe we create a new one called frame for animated. I'm not sure. But it gives us the ability to then animate this sprite like we want to. And then once we have that working, well, actually we have it working. So what we can do, let's try this. This might be cool to do. So right now, what we were doing is we were setting the player state to dead. Let's do this. So I'm going to load the type of explode. Let's also initialize the frame to 0 and the timer to 0, so that now when we hit it, the ship should explode, or endlessly explode. Okay, so that's kind of cool. I got much more entertainment out of that than I think I should have. But that's kind of great. All right, so let's see. So basically, instead of doing the ending here, compare it to 8, and if it's 8, then what we want to do is we want to load A with 0 and then store A into entities type 0, type X, and that will remove the explosion from the entity list. So that didn't work exactly right. compare it to 8. Load a timer. Oh no, not timer. Oh no, that's fine. Compare load a data x. Compare it to 8. Oh well, yeah. Branch if not equal to that next label. There we go. Awesome. What am I using? So what am I using to create and edit the sprites? Right now, honestly, I'm just kind of using, I have Photoshop. So, I mean, this I pulled from Open Game Art. That's Zorchenheimer, I think is how you say that. So this is from Open Game Art. I don't know if this will be the final thing that I use, but I just needed an actual explosion so that it looked decent. This player sprite, I drew that by hand and exported the PNG and then brought it into this entity tool and kind of fixed up the palette. So that's what I've been doing. I did start playing with a sprite recently, just because I know people who really like it, and it was useful for looking at the animation and making sure it looked okay. But I haven't really settled on a graphics utility. Yeah, so as far as bringing assets into the name table, I know some people like the screen tool. I don't know. I mean, it's pretty straightforward, but that's why I'm working on my own thing, because I just wanted to be able to have control over how it all worked. I didn't want it to be purely focused directly on the char ROM setup. So this, this is all kind of defining a project within a single folder, and all of these assets are kind of just picked up by what's in the folder, and then I've added in things like being able to add collisions to the metatiles, and then when you export it, it generates a bunch of files that then get built into the assembly through InkBin and include. Yeah, I've used YYCHR. It is kind of a pain. I mean, it's not. The issue is when you use something like Photoshop. Photoshop is arguably easy to use, but the problem is then you run into these problems where even when you're telling it to use a palette like when you're telling it to use a palette that's the same as the NES palette, if you don't get values that match the NES palette indexes, then when you bring it into something that is expecting that, like my asset tool here, the PNG looks okay. Sometimes the palette, the 4-color palette is okay sometimes, but for other things like the explosion here, you can see the palette is wrong because it's got a bunch of other colors in the palette. So what I've done is that after you bring it in, you can modify the palette just for the sake of ease of use, for me to be able to kind of mess around. So if I'm like, I don't like this red color anymore, you can click on this and select a different red, and you can see it updates it here. And if I say I want green for some reason, whatever, just gives me some options in terms of what I can actually do with my sprites here. Obviously, it's not ideal that everybody is building their own tools. I mean, that's one of the things that's kind of interesting about the NES homebrew scene, is that you have so many people building their own tools, and I'm certainly not claiming that my tool is great or better or anything, but I'm hoping that it will get to a point where other people can use it. I will actually make it available for people to use at some point, but it's still too early on. It really doesn't handle a lot of things, and we were having a conversation about this in the Discord. You know, I mean, every game has its own sort of unique capabilities and needs, and so it makes it hard to build a general purpose tool. If you look at something like NES Maker, you know, they're building the different modules and they have the different things that will handle that. But I'm curious to see how they're going to be handling these different modules with all the different assets being so different and the way that it's handled being so different. So no, it's not on GitHub or anything yet. I will actually put it on GitHub at some point soon. Even if for some reason I stop doing this and I don't end up finishing the game, which I don't think is going to be the case. I've already invested so much time and effort into this, and I'm having a great time learning all of this. I will definitely put this on GitHub. As I mentioned earlier, you know, right now, the way that it's written, I mean, man, it's just, you know, it's not to break my streak of not cursing, but it's kind of a shit show at the moment. But that's because it's, like I said, as I've been going through, you know, all of this is me kind of figuring it out as we go. There's definitely stuff in here that is not optimal. There's stuff in here that's just kind of gross code-wise, but you know, it's working. So I will put this out there once I have a better understanding of how this is all coming together, and then can kind of organize this a little bit better, because also all of the interface stuff, like the lists are and the buttons are custom GUI elements that I've built in the asset tool, with the hope that this might be cross-platform someday, soon, maybe. I don't know. But we'll see. Yeah, 6502 is fun, and it's pretty straightforward, and you know, really it's just having the patience to understand how it works and piece it all together, and churn through all the code that you need to write by hand versus writing C and letting a compiler do it for you. So it's not really that hard, and in fact, you know, getting stuff to appear and happen on the NES at the very beginning is really not that hard. It's when you start getting into like actually making a game and having to manage assets and input and different graphics and palettes, that's where it starts to get complicated and difficult. But I'd say, like, you know, any of their systems up to the even the Game Boy Advance, which you can do C programming for, and I have done C programming for, you know, they're all very similarly architected, which is really nice, because once you kind of learn the NES, as you progress, you get a sense of, oh, this is the same as the NES, but it added these things, right? Like the Game Boy Advance has the same concept of how you manipulate your sprites and the different kinds of background layers, but it's not as restrictive. You aren't restricted to the same number of palettes. And the palette colors, and there are 4 background layers instead of just 1, and what else? But it's a logical progression across the different stages of development for those systems. So it's really cool to kind of see this at the beginning and see how that progression goes. I've really enjoyed working with it, and even I think to some extent the Nintendo DS worked similarly, because essentially if I'm remembering right, it's, you know, just a Game Boy Advance where they kind of tagged on 3D 3D rendering capabilities, and so you have the ability to tell which screen is the 3D screen and pass in your vector threes of the vertices that you want to render into it. But it's still at the core got a lot of the same concepts to it. My goal is to reverse engineer old games. Figured best, yeah, and that's what we did early on in some of the other streams, like the status bar here that we're using in the game. If you look at it, it's easier to see when the game is scrolling. And what you got to do is you've got to change it to, let's see, so if you change the so Messen lets you do what a lot of other emulators do, which is tell it where you want to see the scroll position. So I'm doing it at the end here, and what you can see is that the scroll position of the screen is here for the status bar. And so what it's doing is it's drawing the screen on this part of the screen, and then it's got the status bar on this part of the screen memory. And the reason for that is because we're just essentially flipping from this one to that one when we hit the bottom here based on a timer. And I got the idea to do that from looking at Guardian Legend, because that's what they do. And there's so many games out there to pick and choose from to see how they do it. The real challenge is just having an emulator that lets you see what they're doing accurately enough, and I can definitely tell you that Messen is pretty amazing, and I've said it in other streams too, that Sour, the developer for the emulator, has been pretty good at, I mean, he's even commented on streams where I was having a problem with the emulator, just letting me know that it was fixed or that it's a known problem and that it'll be fixed in an update. So he's on top of it. It's really cool. Anyway, I've kind of rambled on here, and we're at almost 2.5 hours, but I'm super excited that this is working and that the ship actually explodes. I don't know why that's so satisfying to see that, but I guess it's because we've actually got something showing some real progress here. So now technically, although I'd like to have some actual some explosions that are unique to enemies, we could add those explosions to the enemy flyby entities when they get shot down, have an explosion there. No, that's awesome. I'm so excited that I got that working. Now it'll be even more exciting when the asset tool can do that, and I don't have to go manually modify the code to make that work, but one step at a time. Yeah, bank switching on each frame, you can do that too for animation that's cycling back and forth. A lot of times games will do that for things like, if you have a background of grass waving in the wind, that's typically how that's done, or water cycling, although things like water and other elements that are very cyclical in the way that they're drawn, you can do that with palette rotation too. That's another trick. So if you have these 4 palette colors, you can 3 palette colors really, you can cycle through the colors by shifting them around and around, and it makes it look like there's movement even though nothing is actually moving on the screen. It's just the colors cycling around. That's an old game programming trick, so it's been around for forever. Have you ever seen Bad Apple ROM? Some of the stuff that they do in that one. No, I haven't seen that. I'll check that out. Is that a YouTube thing, or I'm not familiar with Bad Apple ROMs. But I'm going to wrap up the recording here. As always, thank you for watching the recording, and if you want to tune in live on Twitch, it's Mondays and Thursdays at 9 p.m. Not next week, but the following week I will not be streaming because I will be away on business, so I will not be able to stream. I will be in a completely different time zone that will make it difficult to stream at 9 p.m. or a useful time, I think. So I'll remind you next week too, but as always, if you want to reach out to me on Twitter, it's at Clearvis. I'm on Nintendo Age. I can also be reached if you comment on the video on YouTube. And yeah, thanks for watching, and I'll see you next time. Have a great weekend.